Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting concept in the subject electrical and electronics engineering. We will see the working of SCR, right? In previous video we have seen the construction of SCR, and today we will see the working of SCR. We will see the working modes in detail, right? And I would recommend you people to go to the previous video and understand the construction of SCR so that you can able to easily understand the working of SCR, right? So we will start the working of SCR in this particular video. So before starting the working, right, we already know SCR has three junctions J1, J2 and J3 and has three terminals anode, cathode and gate, right, which I have explained in previous video. Please go through that video, right. Coming to the working modes, right, we have already seen it has three working modes, that is in three modes of operation. One is forward blocking mode, forward conducting mode and reverse blocking mode, right. Whereas in forward blocking mode it is an off state, and in forward conducting mode it will be on state, and reverse blocking mode it will be off state, right. To understand this particular operation, you consider only two things. One is with the gate, another one is without the gate, right. That is whether we are going to give supply for the gate terminal or we are not going to give supply for the gate terminal, right. With that you can easily understand, right. So now first thing is forward blocking mode. We will see what is that, right. We consider only circuit without gate now, right. So we are going to consider an SCR without gate, right, and that is where it is acting as a forward blocking mode. That is, we are not going to give any particular voltage to the gate terminal. We are leaving it as open. We are leaving it as open, right. So if we are leaving it as open, now we already know what is the condition for SCR. SCR has to be forward biased, right. So for forward biased, we know this is anode and this is cathode, right. So I'm giving positive terminal to anode and a negative terminal to cathode, correct, right. So by giving this forward bias, now what will happen, I'm giving positive to this P and negative to this P, right. So what automatically what will happen, this junction J1 is forward biased and J3 is forward biased, correct. J1 for positive, for P I'm giving positive, and for J3, right, for N I'm giving negative. So obviously J1 and J1, J3 are forward biased. Forward biased. Whereas J2 is reverse biased. J2 is reverse biased. Sir, how you are saying J2 is reverse biased? You see here, you are giving positive here, right? But J2 here it is N, right? And similarly, you are giving negative here, so it is positive here, so it will be a reverse biased, right? So junction J2 is reverse biased, right? Now, what is the working here? Now you have to understand the working. So to understand the working, you take the VI characteristics. I consider this as voltage and this is as current, right? So you have given forward biased voltage. So if you are going to give forward biased voltage, what will happen? The P side it is connected to positive side is connected to P terminal. So the majority carriers here, right? It is P. So the positive sign, because of positive, what it will do? It will ripple. It will ripple and it will go across this particular junction, right. Similarly, you can see here this electrons here, right. We are giving negative terminal here this side, and the electrons here will move towards this side, right. So from this particular P, the charge carriers, the majority charge carriers holes will move towards the cathode, and similarly the electrons from cathode will move towards anode, right. But J2 is reverse biased here. J2 is reverse biased, right? We already know that if it is forward biased, then there is chance of movement of charge carriers, whereas if it is reverse biased, there is no chance of movement of charge carriers. So the charge carriers here, because of the forward bias condition, it will cross J1 and similarly J3, but they will not be able to cross J2, right? Either the holes from this side or electrons from this side will not be able to cross J2. So no current will flow, right? So only there will be some leakage current due to minority carriers. So whatever voltage which you are applying, the SCR, it will not be conducting, it will be in off state, right? It will be in off state. Only leakage current, only small leakage current will be going on, right? So that is why this is called as forward blocking mode. Forward blocking mode where SCR will be turned off, it will not be turned on, right? So when it will be turned on, when it will be turned on, right? For example, now if you go to increase this voltage, if you keep on increasing this voltage, now what will happen, right? The charge carriers will gain more strength, right? So that it will break this particular junction, right? J2 will be broken, right? Because of avalanche breakdown. And because of that, what will happen? There will be a sudden drop in voltage and increase in current. Increase in current. I, right? Why I am saying there is drop in voltage? Because whenever there is an increase in current, there will be a drop in voltage, right? So this particular voltage, where, right, where the SCR will be turned on, that is called as forward breakdown voltage. Forward breakdown voltage. After this breakdown voltage, the current will increase. If you want to understand this very clearly, now consider this J1, you consider three switches here. J1, right? J2 and J3, right? And this is the circuit. Now we consider this J1 as forward bias, so it is closed. J3 is forward biased, so it is closed. J1 and J3. This J2 is reverse biased, so it will be open. So when it is open, now what will happen? No current will flow, right? So no current will flow. So SCR will be off state, right? But if you keep on increasing this forward biased voltage, what will happen? This junction will be destroyed, right? That depletion rate will be completely gone, and you'll have only these two junctions. So automatically, what will happen? The current flow will happen. Current flow will happen. Now, sir, why there is voltage drop here, right? Before increase in current. That is because if you take silicon, we know that silicon barrier potential is 0.7, right? And here also you're using here also one junction, so it will be 0.7. So totally there will be 1.4 volt, right? So even though you are increasing the voltage, it can able to withstand only 1.4 volt, right? After which it will convert everything into current, and that is why, right, after breakdown voltage, you can see there is small drop in voltage and then sudden increase in current, right? And this region where conduction takes place is called as conductive region. That is called as conductive region, right? And now we consider this condition as forward blocking mode, that is without gate, right? So whatever I explained here, you can see here, positive voltage is given to anode, negative voltage given to cathode, and it is gate is open circuited. So due to the SCR will be turned off until the breakdown voltage happens, right? So J3 is reverse biased, sorry, J1 and J3 is forward biased, and J2 is reverse biased. Whatever I explained, that is what given here, right? And this is called as forward biasing condition, that is forward locking mode, because the SCR is turned off, right? Only after breakdown the conduction will take place, right? Now you consider the other condition with the gate, that is with the gate, we call it as forward conducting mode. What happens with the gate, right? The same thing going to happen. That is, this is forward biased, anode is forward biased, right? For positive voltage is given to anode, negative voltage is given to cathode, right? And now positive supply is given to this gate terminal, right? And negative is already given to cathode. Even here, right? Between cathode and gate, cathode is negative, and even here between anode and cathode, cathode is negative, right? Now what will happen, right? Now because of this forward by forward voltage at gate terminal, now what will happen? Already this is forward biased, so like previous one, J1 and J3 is forward biased, whereas here we are given positive voltage to gate, so J2 is also forward biased. J2 is also forward biased. Now what will happen, sir? Now how the SCR will be turned off? The working will be same. The working will be same. That is, there will be small leakage current, right? And then after that, there will be a breakdown voltage, and there will be sudden increase, right? The only difference here is, right, without this supply voltage, we need more voltage. More voltage has to be applied for breakdown to happen, right? Whereas if gate is given as positive terminal, this breakdown will happen very easily, right? It will happen very easily like this. Like you can see here, till here it looks the anode in forward blocking region. Till here you are increasing the voltage, but with the gate terminal, we don't want to go. We don't want to increase to such extent. With few voltage, right? With fewer voltage, the SCR will be turned down. It will go to the conduction mode, right? That is the working of forward conducting mode where the SCR will be turned on with lower voltage when compared to the forward blocking region, right? Even here, there will be a breakdown voltage, only then the current will flow, but the breakdown voltage will be very less. Whereas in forward blocking mode, right, we have to constantly increase this forward bias voltage, right? Because we are not using gate terminal there, right? So you can see here, this is forward conduction mode, right? Whereas the breakdown will happen very easily because of the gate terminal, right? So whatever I explained here, that is what given, right? So the junction J2 is also forward biased, right? And here the depletion region will be broken very easily because of the forward bias voltage on the gate terminal, right? And the minimum current to require to maintain the SCR in on state is called as latching current, right? And now we see the other mode, which is reverse blocking mode. In reverse blocking mode, very simple. You don't consider the gate terminal, right? Now what will happen here? Here you're going to give reverse bias condition. That is called as reverse blocking mode. Same like forward blocking mode. No current will flow because J1 and J3 both are reverse biased, and only J2 is forward biased. J2 is forward biased. Right? Right? No current will flow. Only there is only small leakage current will be there, right? And if you keep on increasing, what will happen? Even this J2 will break down, and there will be a sudden increase in reverse current, right? And this is called as reverse blocking mode, right? So you can see J1 and J3 reverse bias, J2 is forward bias, no current will flow, there will be only leakage of current, right? And if you keep on increasing, avalanche breakdown will happen, that will damage the SCR, and the J2 junction will be broken, right? And it will current conduction in the reverse direction will increase. That is reverse blocking region, right? Now this is PA characteristics where you can clearly understand. So you can see here, in forward blocking mode, the SCR will be turned off. So only leakage current will go. Leakage current will happen from 0 to A, right? And as after breakdown voltage, what will happen? There will be a drop in voltage and then a sudden increase. This region is called as forward conducting region, and this region is called as forward blocking region. Similarly, at the reverse direction, there will be initially small leakage current, right? And if you keep on increasing, SCR breakdown will happen, that is avalanche breakdown will happen. The SCR will completely get damaged and the reverse current will flow. This particular voltage is called as reverse breakdown voltage, whereas this particular voltage is called as forward breakdown voltage, and this is called as forward leakage current, whereas this is called as reverse leakage current, right? This is the VA characteristics of silicon control diode. And you have to understand one thing here. The question can be asked uh, to explain VA characteristics of SCR alone, right? Instead of working, if they ask you explain only VA characteristic of silicon controlled triode, he can explain this same graph, right, with the working, right? How to explain it? You have to explain, right? You will take this, you can mention like this, right? You take this 0 and A. 0 to A. 0 to A is considered as forward blocking mode. Forward blocking mode. In forward blocking mode, what will happen? Junction J1 and J3 are forward biased. J2 is reverse biased. You will explain that, right? And after this, this is forward conduction mode, right? What happens in forward conduction mode, right? You will give gate supply, right? And then the same condition is followed, but it will increase, the breakdown voltage is decreased because of gate supply. All these things, whatever we explain, you will explain it, right? And similarly, this O and E is called as reverse leakage current, after which breakdown happens and then the current will increase. All this you can explain region by region. You can see here, this is how you got to explain VA characteristics of SCR. Forward blocking region, OA is forward blocking region. Then you got to explain that working, right? J1, J3 forward biased, J2 is reverse biased, right? And SCR will be in off state. And in forward conducting region, the same condition, but the breakdown will happen very easily, right? And the SCR will start conducting, and here you will give gate supply. And similarly, in reverse region, OE, that is called as reverse blocking region, where the SCR will be turned off, no current will flow, right? Until you increase the reverse bias voltage, the SCR will damage and, and the reverse current will increase. This is how we have to explain the VA characteristics, right? So, the applications of SCR, coming to the application of SCR, it is used in switching and power control. It has a lot of applications. It can be used as switch, it can be used in voltage regulators, it can be used in DC to DC converters, AC to DC converters, battery chargers, control circuits, DC circuit breaker, AC power control, controlling motor speed, right? Light dimmer, and similarly fan speed regulators, right? These are the applications of silicon control rectifier. So today what we have seen is we have seen the working of silicon control rectifier. What are the different modes of operation, right? And we have explained what is VA characteristic of silicon control rectifier and applications of silicon control rectifier. I believe this video will be very useful for you. Thank you, my dear students.